All right, hello AP Statistics. This is section 3.1, scatter plots and correlation. You're going to need a graphing calculator and your notes, but especially a graphing calculator. Have that handy. There's a lot of little details that you're going to have to include. All right, here we go. All right, scatter plots. I got two definitions. The first one is an explanatory variable versus a response variable. In psychology class, if you ever took such a class, they are sometimes noted as the independent and the dependent variable. And let's define each. We'll start with the second one, actually, your response variable. Your response variable measures the outcome of a study, quite simply, all right, based off of your explanatory variable, okay, which may help explain or predict change in a response variable, okay? It's kind of like your cause and your effect, okay? What are you doing here with your explanatory variable to provide some type of change in your response variable, okay? So here's what I got. I've got Michaela Hanks, who was an absolute champ on the golf course. In fact, kind of a weird situation. The hotter it is, the better she performs, okay? Which is super helpful when you live in the state of Arizona. Listed below are outside temperatures of Michaela's respective golf scores for 10 random matches, okay? Assume that all matches are on par 72 courses with similar difficulty ratings. Keep in mind that a better golf score is one that is a lower score. Okay, I'm going to ask you to plot the points on the graph. We will describe the relationship, and then we will find the correlation coefficient R. All right, so take a moment, if you don't mind, and what I'd like you to do is pause this, plot the points on your paper, and see if there's any type of relationship between temperature, that it is outside in degrees Fahrenheit, and her score. All right, and I'm going to do the same. Okay, so that's how my points look like. You can see that we're counting by twos, not only horizontally, but vertically. So I'm able to plot all those points. And here's what it says. It says describe the relationship. Okay, now, as I look at my points, I can see the points have some type of pattern collectively. Okay, and what I'm going to share is this. We have, I'm going to write three things. Okay, and you're always going to have three things when you describe the relationship between your input values and output values as they form a line. Okay, the last of your three things I'm just going to say is the word linear. Okay, what word is in the word linear? Some of you are like ear, and that's true. Ear is in there, but line is the more important word. Okay, line is the more important word. So we do have a linear relationship. Okay, it's actually a very strong relationship because the points fit pretty tightly close. What would be this like imaginary line that would pass through those. So I'm going to say we have a strong. Okay, and then the last thing I'm going to put in the middle here is whether it goes up or down. Okay, I'm not going to write the word up or down. As you read this from left to right, okay, as x goes in the more positive direction or your input values go in the more positive direction, you'll find that it actually has a, what we'll say, a negative relationship because it goes down. Had it go upward, then you would say a positive. Okay, so we have a strong negative linear relationship, and I'm going to say between, and I'm going to write her input values and her output values. So I'll say temperature, okay, outside, okay, and it's in degrees Fahrenheit, and her score. All right, now some of you will ask, do I have to write all that? And the answer is yes. Okay, it's a very popular type AP question, is to describe a scatter plot, and they want all those things. Okay, so first, you always have three parts. Okay, don't leave one of them out. If you leave one out, they'll take off a third of your points. Okay, and the second thing is make sure you put it in context, which is this, your X, and here is your Y. Okay, so again, typically the last word is always linear. Usually it's either positive or negative. There's really not any other option there. Otherwise, it doesn't really have a relationship. It would be kind of like a zero relationship. And then hopefully your relationship is strong. okay? If you find the points are flared out a little bit, you could use a different word like moderates or maybe even moderately strong, okay? But it's even possible to say it's weak, but weak kind of means that you're probably not going to have a linear relationship then. But I usually say usually see strong or mildly strong, or maybe just moderates, okay? And then beyond that, there's really not much of a linear relationship. Now, sometimes we want a little bit of more definity in terms of whether something is a strong or a moderately strong versus moderate relationship. And what we do is we have assigned a calculation for how your scatter plot points fits a line, okay? Obviously, the closer they form a line, the stronger the representation is, okay? And we're going to do so with this formula on the bottom, and we're going to call that the correlation coefficients, okay? Now, this is kind of a long, ugly formula, okay? And you're like, dang, that doesn't look pretty, but I will show you a calculator method that will help us move through this a little bit better. So here's what I need you to do. I need you to take a moment, okay? I'm gonna go back a screen just for a second. And I want you to look at these 10 data points. And off to the left here, I'm gonna put something here. I'm gonna put in L1 and L2. I want you to plug all the temperature readings, okay, in the order that you see them, okay, in your L1. And then in L2, match up the corresponding score based off those temperatures within that list, okay? Take a moment and do that. And then once you have that done, okay, we'll move on to this next screen here, and I'll show you what to do, okay? So take a second and do that. Okay, once you have those in your L1, here's what I'm gonna have you to do. It's a similar command that you've done in the past. What we're gonna do is we're gonna go to Stats, okay? We're gonna scroll over one to Calc, okay? And something slightly different, I'm gonna go to 2. This is called, I think it's called 2var stats. Yeah, 2 variable statistics. Okay, and what that means is this is going to do calculations for both your X's and your Y's. Okay, so hit that. Make sure that you have L1 and L2 in your commands. Okay, and as you work that all out, you're going to find a couple important features. Okay, I'm going to write these down underneath my little picture frame here, and I'm going to put my X bar first. Okay, my X bar is 94.9 with a standard deviation of 10.429. Okay. And then if you scroll down, you're going to get some Y's. Okay, so your Y bar is 74.8, and your S of Y, okay, which is your standard deviation of Y, is 6.45. Sorry, excuse me, 6.54. It's a harsh 6. Okay. There you go. And now that I have those, okay, then I can go through and work with this monster ugly equation. Okay, so take a second, make sure you got those. And once you do, okay, then here's what I'm going to have you do. And hopefully you can do this slowly, okay, and pause this as you need to so that you can catch up, okay, and do the things in your calculator to help get the correct results, okay. All right, so if you found these, okay, let's keep these marked down and handy. Maybe write those down on your note sheet. I'm going to go back to Stat. I'm going to hit Calc. Let me write those down. Stat. Actually, don't hit Calc. Just hit Stat. Hit Enter. Okay, and you're going to highlight your L3. Okay, so not only move it up there, don't put it underneath the space underneath. A lot of people accidentally put it here instead. Highlight your L3. Hit Enter. And what I'm going to do is I'm going to do this part here. Notice that it kind of looks like a z-score. It's X minus the mean over the standard deviation. I'm going to do that part in my L3. And you can see what I have right here. Now, when you write X sub I minus the mean over the standard deviation, you're taking all these values, okay, that are your X values, basically your temperature values. You're subtracting the mean for every single one and taking the standard deviation for every single one. And you're like, that would take me a long time to do all 10 of them. Okay, so here's what you're doing in your L3. Okay, you're taking all your X's. Okay, notice this is in parentheses. So L3 is highlighted. I'm going to put a parenthesis there. I'm going to type L1, which is just seconds and then the number 1. Okay, minus 94.9, close your parentheses, those are important, divided by 10.429. Parentheses in your numerator have to be important, okay? They are important. All right, so once you plug those all in, you're gonna get values that look like this. Check your work to make sure that that matches, okay? If you're not quite there, hit pause and try it. Okay, now, next piece, okay? We're gonna go to L4 and we're gonna highlight it, okay? This little y sub I means you're gonna take all your y values, all your quote unquote golf scores, subtract the mean to every single one, and then divide by the standard deviation of the y's. And you're like, that would take me forever to do all 10 of those, all right? So let's do this. In L4, I'm gonna write this command using parentheses and knowing that all my y's are located in my L2, okay? This is where all my x's are, those are where all my y's are. Okay, so L2 minus 74.8, okay, which is what you found over here, divided by 6.546. Work that out, and you now have these two items right here, your L3 and your L4. Okay, now, what am I going to do with those items in L3 and L4? Well, there is a time sign in between it, okay? And what I'm going to do is highlight my L5, okay? And L5 is L3 times L4. That is L5, and that's what I wrote in here for L5. Again, highlight that L5, just hit L3 times L4, and you're going to get all this data. Okay, so I have done most of this work just using lists and letting the list do the math for me, kind of like a spreadsheet. Okay. All right, and so I'm almost done. I have 2 steps. I've done all the variations here of the x, okay? Take all the x values, subtract the mean, divided by the standard deviation. Do the same thing for the y's. Those are in each L3 and L4. We multiply those together. All of our important data is now in L5. I need to use the sigma notation, which means add those guys up, okay? How do I do that? Well, you know how to add things up. We did that in the very first command in 1.1. It's a 1var stats, and you got to put in here L5. Okay, so second and then the number 5. Go down and hit calculate, and you're going to get all this stuff. And of all those things, what is important? Well, it's the sum of the x's. That's what you're looking at. This is the sum sign. Okay, so my r is equal to, well, it's 1 over n minus 1. We'll talk about that in a second. Times this sum, and the sum is negative 8.908975146. Okay, and then of course I got to multiply that by 1 over n minus 1. And you're like, what is n? N is the total number of points. Let me write that near my head up here. N is equal to the total points, or coordinates. And of course, I've got 10 of them, so 10 minus 1. All right, and if you do this math, this is basically 1 over 9 times this monster, okay? And so if I take 0.89, sorry, not 0.89, 8.9, okay, 0.8975146. I probably don't need to do that many, but that's fine. Divided by 9, okay, I'm going to get an R value. Of course, it's negative, of 0.989886, and it goes on a little further. Okay. And that's how you do this. Okay, now you're like, what is R? I don't get what R is. R is a measurement that we're going to talk about in just a second, so hang tight, okay? But I'm hoping that all this work makes sense in terms of how you calculate this by using the formula, all right? And again, this is a lot of stuff, okay? Will you have to memorize that? Probably not, but you'll practice it enough sometimes where you won't have to have it memorized because it'll just kind of come to you, okay? Now, here's an alternative way, okay? And you're gonna like this way better. I just wanted to show you how the formula works, but here's how things go, okay? First thing you have to do is something called diagnostics on. You only have to do this once, meaning after you do this step, you'll never have to do it again, all right? It's a way of transform your calculator to have certain readings, and you need to have this on. So Here's what you're going to do. To turn your diagnostics on, you're going to hit the second button, and you're going to hit 0, which is catalog. Okay, second catalog. And then you're going to have to scroll down because this is alphabetized from lowest command to highest command. And you want to go all the way to diagnostics on. Don't get that confused with diagnostics off. Okay. And once you see it and highlight it, hit enter. It'll say diagnostics on, and you'll hit enter again. It'll say done, and you're like, it feels very anticlimactic, but that is really all it is. Okay. Now that you have that on, here's what I need you to do. Must do it, otherwise it's not going to work for this problem. I need you to go to stat, just like I did before. I'm going to write this underneath the third window here, stat. And I want you to scroll the calc like we have before. But instead of going over to 1, like we have been the last probably 50 times, I need you to go down to 8. Okay, it says linreg A plus BX. Okay, I need you to highlight it and hit enter, or you can hit, you can either hit the 8 or you can just scroll down and hit enter. Okay, and you'll see a command that looks like this, or a screen. And you got to make sure L1 and L2 are there. That's probably going to be the default unless you have something funky in there. Change them. L1, by the way, is seconds and then the number 1. Okay. And L2 is seconds, of course, and the number 2. Okay. And here's an important feature. Make sure you have a Y1 there. Okay. How do you get Y1? For most of you, all you have to do is hit alpha button, which is the blue button. Okay, the blue alpha button, and then hit the trace button, and it should pop up. Okay, if you don't get that, if it gives you like a graph instead, you're like, what's wrong? Okay, here's the alternative way. Go to vars, go to yvars. Okay, that's like a slide over. Go to function, and then you'll see the Y1. So that's another way of doing it. Most older calculators, that's the only way you can do it. So you may have to hit pause with this, okay? Make sure you get back to this original screen. You don't have to go back to here if something didn't go right, all right? But when you hit this command and you want the Y1 there, this is one way. If you have a newer calculator, that's probably the preferred way. If not, you have to do it this way. There's a vars button, and then just follow those others. It's 3 more buttons after that. Okay, it's pretty easy. Okay, after you hit this Y1, hit calculate. And the item that you want here is on the bottom. And you'll notice it says negative 0.9899. Okay. Some people are like, I'm going back to my old screen. Can I do it that new way versus this way? Yes, I did it this way so you can see how it's done. However, you're always invited to do it the way that I just showed you right here. Okay. But this alternative way, which is a quicker way, is also done. Just do this. This is how you show your work. Just say, hey, I use my TI-84. I use this command 8, linreg A plus BX, and that is showing your work, okay? And you'll just say, hey, R is negative 0.9899. People are like, can I do that on my test? Yes. Can I do it on my homework? Yes. Can I do that on my AP test? Yes, you can, okay? That's a shortcut that's allowed, and as long as you write your commands, okay, that is considered showing your work, okay? So this is allowed. Hey, now, I've shown you how to calculate R, and you're like, what does this mean? Let me show you. Okay. First of all, definition from the book. What is the correlation coefficient R? It's a really good definition. It kind of makes sense in terms of the words they use. It's really well done. It says measures the strength and direction of a linear relationship between quantitative variables. Okay, so strength and direction using 2 quantitative variables. Okay, so let's think about the one that we just did. All right, you had almost a perfectly straight line. Okay, and it was close to -1. It was negative 0.989. Imagine if it went in the positive direction, and it actually was a perfectly straight line. Okay, if that's the case, okay, we say is the maximum positive correlation. It's really kind of like the perfect correlation. And we represent that with a representation of R is equal to 1.0, okay, or just R is equal to 1. So a perfectly straight line where your points in your scatter plot are just pure, okay, you will say that your R is equal to 1, which means that your r will never be larger than that. R always has to be less than or equal to 1. If you ever do an r value and you get a calculation bigger than 1, it means you made a mistake somewhere in your math, okay? So go back and check it out, okay? All right. Second thing is this. As your points kind of deviate from making a straight line, they kind of delinearize, if that makes sense, and they scatter about, you'll notice that your r value, okay, will start to approach 0. Okay, so r was perfect here. That was 1. Here, as the points kind of scatter a little bit, okay, notice that dropped to 0.8. Okay, and if you kept doing it, or the points scattered even a little bit further and further, you know, maybe I put a couple more out there, maybe it would drop to 0.6. But the idea is that if you get to a point where you can't draw a positive slope through your picture, okay, then that's when you have 0 correlation, okay, or r is equal to 0. Okay. Now, similarly, as we talked about this before, okay, this is perfect negative correlation, okay, and that's when all your points go through a straight line. And instead of representing that with a positive 1, you'll say it's a negative 1. Okay, so what I know is that your r will never be lower than, a negative 1. Okay, and I don't need that there. But so in the end, I'm just going to rewrite this so it looks a little bit more clean. Your r is always going to be an inclusive to negative 1 to positive 1. Okay, and same idea, as your points begin to separate, you know, maybe there's a line that fits those points somewhat, okay, but again, as those points seem to separate around the line, your r gets not smaller, but closer to 0. Okay, it gets closer to 0. All right, good. So let's take a look at this definition. We kind of understand the relationship, hopefully, between r and negative 1 and positive 1, and I wrote a negative 1 there, sorry. But let's do this. It talks about strength. As values get closer to 1 or negative 1, that means your points, again, get closer and closer to making a straight line. The direction just says this. If your r is positive, okay, that means your slope is positive. Okay, it doesn't tell you what the slope is. It just says that it's going positive in some direction. Okay, and of course, if your r is negative, that means your slope is negative. I don't know how negative the slope is. I just know that in some way it's negative. Okay, let me draw a little picture up here just to kind of reiterate. Let's say I have, again, r is equal to 1, looks just like this. Okay, what I can also share is that if my slope, okay, is almost vertical but still positive, and the points all make pretty much a straight line there, that's still r equals 1, but it's no more of a strength than what you see here. Okay, similarly, if I had something that was just barely horizontal, just barely positive, okay, but again, if all the points made a straight line, that's still an r of equal to 1. Sorry. All right, so keep that in mind. All right, that r is not a slope. Okay, all it tells you is the direction of your slope, whether it's positive or whether it's negative. Okay, now another piece is that notice that when we describe this here, we don't use explanatory response variables because correlation, we say, does not imply causation. Okay, and what I'll do is I'll show you something called crazy correlations, where you actually have a relationship that looks like it's pretty strong between two very strange variables, but there's really no cause and effect there. Okay, they're just numerical variables that seem to have some type of relationship, and it looks like it's linear. However, it's not cause and effect. Okay, correlation is not resistance to outliers. Okay, and you'll notice over here that I have this perfect. This is the very last graph. Just want to make sure you see that almost perfectly straight line. In fact, for those points, it probably is. Okay, but I've got this ugly outlier up here. All right, and if you're to draw a line that fits all those best, you can't just draw it through here because that doesn't identify this point on the top left-hand corner. So if I had to fit a line for all of these, it's actually probably going to stretch it up just a tiny bit. Okay, and in doing so, okay, R got changed, okay? R is now not 1. Because of this outlier, my R dropped a little bit to 0.71, okay? And what that means is it has less strength in terms of making a straight line compared to what it used to have, which would seem to make sense based off this outlier, okay? All right, some things to remember. It says correlation is unitless, okay? So while on my previous question, we had negative 0.98, I think 99. That was my R, okay? Keep in mind that I didn't put anything back behind here. I didn't say golf scores. I didn't say anything about temperature. You never put a unit behind an R. It just stays this way. And sometimes on multiple choice questions, they'll try to trick you. They'll have you find R, and you'll write it, okay? And they'll put something on the back, and when they do that, you'll be like, didn't Rothery tell me that I shouldn't put something back there? And you'll say yes. You should not have anything on the back, and you will not make that one of your possible options for correct choices. Okay, so there's nothing behind here, no units. Okay, all right, I think that's all I got for you. This is your assignment. Okay, again, you can use the shortcut, okay, which was stats, calc, and then it was 8, okay, linreg. Okay, A plus BX, okay? And then just make sure you write that command. Just say, hey, TI-84, this is how I found my R, okay? And that is your answer. Don't forget how to describe, okay, your scatter plot, okay? It's either strong, moderate, weak, okay? Positive or negative, okay? And then linear. You have to have all 3 parts there, and then make sure you tell me what X is and what Y is in context, okay? If you have any questions, you holler at me, let me know. I'll be happy to help you out. Here's your homework right here. It should go pretty quick. Have a great day.